Let me share my screen. I'm trying to make this as close to the real presentation as possible because, Charlie, fucking suck. Wow. Okay, cool. Um, Good morning, guys. My name is Ernest, and today I'll be presenting on the topic basic syntax in Go. So before, without wasting much time, let's just get to it. So these are the objectives for today. By the end of this session, everybody here should have a basic overview of Golang's fundamental syntax, and everybody here should also be able to write simple, correct, and efficient Go programs. And at the end of the day, we should all know the basic syntax of Go, and I mean variables, functions, loops, conditionals, and defer statements. So let's get into it. So this is the program structure of Go. Every Go program starts in a package called main, and you can choose to import certain packages depending on what your program needs. And so this main function over here is the entry point of execution. So if you can see this screenshot over here, we see the function main, which is printing a hello world, right? So somebody has raised their hand. I don't know. Let me. Okay, cool, no problem. So yes, this is how a basic Golang program looks like. You have the package declaration, which is over here at the top. If you need any imports, in this case, we do need the format import, right? So we just imported it, and then in our main function, we just call format or print line to print a hello world. So that's just how a basic Golang program looks like. And let's talk about variables. If you already know how to code, I mean, you know what variables are, right? And in Go, you can declare variables in two main ways. You can declare them explicitly with the var keyword, or if you are lazy like me, you can just do an inferred declaration with the colon and equal to. And you can also group variable declarations with var and a parentheses and whatever you want to do for clarity. And also uninitialized variables take on their types zero value. So if you can see over here, name, age, and height are explicitly declared variables because we are telling the compiler that a name is of type string, the age is 30, which is an integer. Okay, so I think there's a syntax error over here, and there's also the height, which is a float 5.9. So let's just do some small examples. I already have a Go project over here, so yeah, we can do that. So if you want to initialize a variable in Go, like we said, explicitly, we can just do var, let's say, age, and tell the compiler that is an integer, so it will be 10, right? And then let's do another one. Let's say name, which is a string, and then we'll call that maybe Ernest. But for instance, if we don't want to be writing the type of these variables every time we declare them because they can become too long, we can use the colon and equal to syntax, right? So just to get rid of this compiler errors, let me try and print age and name like this so that we'll get rid of those errors. But we can also do let's say count and then do this equals to 15. So with this one, the compiler automatically knows that, oh, count will be an integer, like you can see over here. So it says var count int because of this colon equal to. We can also do let's say group equals Golang Ghana, right? And then we can print. So this is how like variables are declared. You will see the colon and equal to syntax a lot in Go programs. So you might as well just get used to it today, and then we can run our program. Okay, so it looks like I have to use PowerShell. So yeah, that's pretty much it for variables. Now, if in case you want to do some group declarations, like we said in the presentation, you will have to use the var keyword with an open parentheses and then just put the variables in there, right? So if I were to give an example, we can do something like maybe var, maybe username, Next, okay, so we can do this by username string, and we can do, yeah, that's pretty much it. I'm coming. Okay, so it looks like we don't need a var over here because there's a var. Okay, cool. And then we can do maybe age int equals 12, right? So doing this, we just group them however you want to, right? Mostly you might use them maybe if you're writing an API and you have like a bunch of API responses that you want to use in the program. You can just use this group declaration to declare them at the top of your program, and then you keep using them wherever you want. So this is also another way of declaring variables. So let's go ahead. And then there's also something called zero values, right? So in Go, there's also a way to declare a variable without necessarily giving it a value. So we can do maybe var, let's say text string. And then when we do this, right? So let me also try and print text to get rid of the compiler error. When we do this, text over here, the compiler knows that it's a string, but since we didn't do something like, oh, text equals text, right? Automatically, the value stored in text is called something we know as a zero value. And a zero value basically means that if you've not given the variable something to hold, the compiler automatically assigns it some value for the meantime. And so for strings, I think it's an empty string. And so if we try to do, if you try to print, let's say what's in text, we can do maybe the zero value of text is text. We can do this, and then, oh, sorry, and it's going to be an empty string, right? So you can see that there's this, space over here. Obviously, we can't see it, but let me do, yeah, like this, so that we'll see what is there. So it's the same thing for other types as well. If we have maybe var age int, so if it's an integer, it's going to take 0. So we can do age like this, and we'll see that it will add a 0. So depending on the type you are using, right? If you've not given some value for that variable to hold, right? The type or the compiler will automatically assign it a 0 value based on the type that the variable is. So that's pretty much it about variables. Let's go ahead. So yes, you can see that. So for strings, the 0 value is an empty string. For integers, the 0 value is 0, and for for floats, the 0 value is zero point 0.0. So yeah, that's pretty much it. And also there are constants, and which are also types of variables. So constants are variables declared with consts and cannot change. And some other types of variables, like I've said previously, include the int, the float 64, the string, the boolean, the byte, etc. Depending on what you are using, right? You might change the types as and when needed. And so for constants, right, we use them when we know that the value of a variable is never going to change. For instance, the value of pi, we know that pi is 3.14, etc., etc., right? So if, let's say, we are using the pi value in our program, and then we know that pi won't change, etc., so we can just give it a const. And so by giving it a const like this, by saying pi is a const, right, we are essentially telling the compiler that, oh, at no point in our program will the value of this change. And so it means that we can't come here and come and do pi equals to maybe 3.15. It will tell you that, oh, you can't assign pi, which is neither addressable nor a map. The long and short is that it's a constant, it doesn't change. So why are you trying to change it, right? So this is also something you might want to keep note of, right? If maybe you're working with something that the value won't change, just use a const instead of the regular var. So yeah, that's also it for constants and basic types. And there's also something called a function, right? If you, again, you already know how to code, you probably know what functions are, but functions are essentially ways that we define reusable logic. And so if maybe you have a program over here, right, this is our main function. You don't want to have everything in your program over here in this main function because it will make everything look cluttered. So we have to find ways to organize them so that we can call and then on call and use them as and when they are needed. Do you get it? So that's what functions do for us. And in Go, we declare functions using the func keyword, right? And so yeah, wherever you see a func um, with a keyword, you know that it's a function. So that's just it. And also, yeah, parameters and return types are explicit. So you must tell the compiler what types your function takes and the type it returns. So if you look at this greet function, for instance, right, you must tell the compiler that, oh, the name you are passing to this greet function is of type string, and also this greet function will return a string. This is like something you can do without. If you are declaring a function in Go, you must tell the compiler the types of your parameters and also the type that your function returns so that it will be better, right? Nobody gets hit. So yes, let's declare some few functions over here. So I'm going to declare a function called func hello. So hello is obviously a function, and let's just let it print hello world, because hello world like this. And now if we want to call this hello world anywhere else, we can just type the name of the function like this, and everything is cool. So now when we run this program, it returns a hello world. Now let's make it more interactive. Let's say we wanted to take somebody's name and then print hello and then the person's name, right? So like we said, the parameter that we pass to a function needs the type. You can't do without it. So let's say we want to say hello Ernest. So we'll give it a name parameter, and then the name is of type string, and also we will let our function also return a string. And then instead of printing it over here, we can do return hello and name like this. So we will need this. What are they saying? Too many return. Okay, so I'll come to that later, which is fine. Now we can do hello Ernest. Hello doesn't have side effects unless return value is ignored. Okay, cool. Let me. So we'll just call hello, and we'll do. And this is my compiler messing up with me or what? Okay, so let me do fmc dot. This is probably not going to work. Let's go issue. Okay, no problem. Okay, cool. Let's see. If not, I'll have to just do a print. Okay, cool. So it worked. So yes, the compiler takes, let me see the compiler. The function takes a string as input and it returns hello plus that string, which is like pretty straightforward. It's like the easiest function you can declare in Golang, right? Also, one thing that you might want to keep track of or you might want to keep note of is that functions can also return multiple values. So if you look at what I was doing previously, right, I was doing a hello, comma, and then the name. So over here, what the compiler thinks is that, oh, it thinks that you are trying to return two things at once. Meanwhile, you only set it to return a string, right? So in Go, there's also a way for you to let your function, what's it called, return multiple things. And so if maybe you are writing a program where mostly where you would see this is in APIs or in whatever function that you're calling, right? You get the results and you also get an error. So most of the functions that you might call in Golang will return these two things. And depending on what you are doing, right, you might want to check if an error exists, and then maybe you change the execution flow of your program and whatnot. But it's something we can also do ourselves. So we can declare some function right here that returns multiple things. So let's say a division function, for instance. So func divide, which is going to take, let's say, A and B, and they are all going to be, let's say, floats. Also, another thing is that if you know that both parameters or all the parameters you are passing to a function are going to be of the same type, you don't have to do maybe A float 64 and B float 64. It makes it very long. So you can just use a shortcut and say, oh, A, B float 64, so that the compiler will know that, oh, A is a float and B is also a float, and everybody is happy. And now we are going to return two things, right? So we can do, let's say, So if you know that your function will return two things, you have to put them in this like parentheses over here. So we can do maybe float if the actual division goes through, and then let's say an error, and then we can open our function. So let's say somebody wants to divide, let's say 10 by 0. We all know that division by 0 is not possible mathematically, right? So we can first check b if b equals 0, then we'll return 0, and then let's print an error. So in the format we can also there's also this thing called error f, where it's just like the printf, but we use it to print error objects. I think the guy presented on it last week. So you can just do maybe cannot divide by 0. If not, we'll just divide it for them. So a divided by b, and then we'll return a null. We return a null over here because no error happened, right? And since we are saying that our function has to return a float and an error, right? This a divided by b will give us the float, and no error happened, so we can just give it a null. So null values in Golang are represented by this nil keyword nil, and yes, that's pretty much it. And so it means that we can call our function in our main function as well, right? So we can just do maybe let's say results, and then error equals divide, and let's do 10 and then 0. So when we do this, right, we know that res will be of type float 64, and then error will be of type error. So now we can check, is error now? So we are trying to check if an error actually exists, right? So we can do if error is not now, then we can say we'll print our error. So we can do fmt.println error, and then we'll just print whatever error message that the function is giving us, which in this case is err, right? If not, so let's do an else. We'll just do format.print line results like this. What are they saying? Missing. Okay, so I need a comma. Cool. Sorry, force of habit. Okay, so now we can run our program again, and it's saying strings should not be capitalized. Okay, it doesn't matter. Okay, cool. So what we do over here is that, so now we can also assign the return values of functions into variables. So this is something you see a lot in Golang programs. And so wherever you call a function, right, you have to check if there's a potential error. For instance, this function returns a float and an error. So we can also assign variables to the results of this function, so that based on what we get, we can change the execution of our program. So over here, we check, if error is not now, it means that if an error object actually exists, we'll print the error to the user. If not, we'll just print the results that we got. So we can just go ahead and run our program. So we get an error, cannot divide by 0, because obviously we were trying to divide 10 and 0. But if we do 10 divided by 5, in this case, no error will happen. So the result will be 2, and everybody is happy. So yeah. Another thing you might also want to keep track of is that functions can also not return anything. You can have a function, let's say func greet, that takes maybe my name, and then I can choose not to let it return anything. In this case, it means that I won't use the return keyword in the function. Maybe it's just printing something. So fmt.println maybe hello name, like this. So we can just call the function here and do greet Ernest. So functions, they can also choose not to return anything. It's not by force that a function has to have some return values over here like this, and Golang is not designed like that. So you can have fun with it. Now let's get to flow control. So with flow control, we are talking about loops, if statements, switch statements, and also defer. I used if conditions over here, even though we hadn't gotten to it yet, but we are here now, so we might as well just take a look at it. And so for the for keyword, quote unquote, is goes only loop construct. So if you are working with a bunch of values, or if you are working with yeah, a bunch of values essentially, and then you need a way to iterate, or you need a way to go over the number of values that you are working with, right? You need something called a loop. And in other programming languages, they have for loops, they have while loops, they have do while loops, etc., etc. But in Go, for is the only kind of loop that we have. And so by default, it replaces the traditional while and also the do while from other languages, which makes looping more consistent. So it means that we can use the for loop for fixed iterations, for conditional loops, or for infinite processes. In other words, infinite loops. So let's do some examples of loops, right? Let's say we have let me get rid of this. Okay. I think we'll need this. Let's say we want to count from 1 to 5, right? So we will need a for loop, because in this case we are looking at values 1 all the way to 5, right? So we need a for loop. And so by declaring a for loop, you use the for keyword, for, and then you need an initialization variable. Mostly you see people use I, so I'm also going to go with I. So I is equal to 0. We don't really have to, specify the type over here. And then you need a condition. So a condition is basically the what tells your for loop how long it should keep running, or not how long per se, but whether it should keep running or not. And so in this case, we want to count from 1 to 5. So it means that as soon as our loop reaches 5, we should stop. And so we'll say, oh, if I becomes less than, while I is less than 5, right? So if I becomes greater than 5, we'll stop looping. And then after each loop, we just want to increment the value of I. So we can do I plus plus, so that after, so we'll start, oh, I is equal to 0. And the compiler will check, is I less than 5? Yes, 0 is less than 5. Then we'll increment I. So I becomes 1. And so it keeps on going. I becomes 2, I becomes 3, I becomes 4. When I becomes 5, our loop stops. So we'll open our curly braces, and then let's say we want to print our count. So we'll do fmt dot print line, and we'll type our count over here, and then we'll print I. But if we run our program, you see that it printed count 1, count 0, count 1, count 2, count 3, count 4, because I started at 0, and it stopped as soon as I became 5. Now we can obviously change this if we want to have fun with it. Let's say you want to count 1 to 5. You can do this so that it will print 1 to 5 for you. And so yeah, but if you are coming from a different programming language and you know what while loops are and what while loops do, the Golang also provides us with a way for us to initialize our own while loop styles over here. And so we can do something like, oh, in while loops in other languages, you can do maybe while I is less than 5, and then you just print, right? In Go, we just use the for keyword. So we can also do for I is less than 5, and then we'll go ahead, and since we don't have I over here, I'm going to go ahead and initialize I as 0. And while I is less than 5, we'll just do fmt dot print line, maybe while loop, and then we'll print our I right here. And then after we print, we'll maybe increment the count of I, so that I will also, or our loop will also know when to stop, because this is a while loop. If we don't add anything, our loop will just keep running forever. So yeah, we might want to increment the count of I. Now, in fact, let me actually take this off and let's run our program. Let me also comment this out. Let's do this and let's see what happens. So you see it keeps printing 000, it goes on forever, right? We don't want that. That's the reason why we add our post statement. That's what it's called. It's called a post statement. After you've done whatever you want to do in your loop, you want the statement to run so that it will run and eventually hit our loop's boundary, which is I is equal to 5 or greater than 5. So I'm going to stop this program, and then I'm going to increment I, so that our loop will know when to stop. So yes, this is like a while style loop in Golang. And if maybe you, for some reason, you want to also do an infinite loop, maybe you are running a web server, or you are running a background job or something, maybe a coroutine self. If you are already familiar with Golang syntax, you already know what a coroutine is. So in most times you might want them to run for forever, infinitely until a condition happens. Or maybe you're building a game that you want it to keep running forever until the user presses kill or something so that you quit, right? You can also use the for keyword for that. But with that one, it doesn't take any variable, it doesn't take any condition, it doesn't take any post statement. It's just the for keyword and some curly braces, and then it will print fmt dot print line. What do we say? Running forever, and then we'll break. Obviously, you know, if you omit everything, you get an infinite loop. But yeah, that's pretty much it. So yeah, but if let's say we don't do this, it keeps running forever, 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 because it doesn't break. So you might also have to, take note of this. Mostly you might want to let it break at a point, so that our loop won't keep running forever and keep taking memory and whatnot. So yeah, another thing I also want to talk about is range-based loops, right? So the range keyword is range. Is Go's way of of iterating over slices or over maps, over strings, etc. If you have a collection of values, or you have a type that's like a collection based type, quote unquote, and then you want a way to loop through these types or these variables, right? Golang provides the range keyword for us that gives us the ability to do that. And with this one, right, it returns an index and then a value. So an index is essentially where you are in the range. Let's say if you have an array, maybe 0, 1, 2, 3, 4. So when we call range, let me put range here. When we call range on this, it returns an index and then a value. So an index basically refers to where you are in the loop, the position of wherever this element is. So indexes start from 0. And so if we are at the 0th element, our index would be 0 and 0. And then if we go to 1, it will be 1 and 1. If we go to 2, 2 and 2, you get a point, right? So that's what ranges do for us in Go. And we can also loop through collections using the range keyword as well. So let's assume we have an array of numbers, right? So in Go, you initialize arrays with this square braces, and then you tell us the type of whatever our array is storing. In this case, it's going to be an array of integers. And then if we want to add some values, we can do that as well. So let's say 10, 24, let's say 78, like this. Now, let's say we want to look through this array or these elements in the array. Let me add more numbers. Okay, cool. So we can just use our normal for keyword, and we'll do, since we are running or we are calling a range on this array, right? And we know that ranges return an index and a value. In for loops that call the range keyword, we also, it's almost a must at this point, right? We must also initialize our index and our value, what's it called, variables, right? So we can do for I, and then let's say n, which, like I said, you can assign the return type of functions into variables. So just like we'll do maybe results and error equals to whatever function call we do over here. That's the same thing we are doing for the range. So we'll call range on this, and then range of nums will print. So let's print I and n. Perfect. So yeah, let's run our program. So we start at the 0th index. So over here, 10 is at the index 0, 24 is at the index 1, 78 is at the index 2, and so on and so forth. So it just provides us a way to, iterate over whether it's a slice, whether it's a map, whether it's a string. You can have fun with it. Mostly when you're writing programs that maybe you would need the index and the value for whatever computation you are doing, the range might come in handy. So it's also something that I want us to take note of as well. And so, yes, the next thing that I want to talk about is the if statements. Now, if statements in Golang are direct and clean. They allow short variable declarations inside whatever condition we have, which keeps temporary variables scoped tightly to the statement. It makes code more maintainable and avoids any side effects. So enough of this long talk. Let's just get into it. Now, Ghost if statements are actually very neat, right? It allows us to declare something called short-lived variables, if you want to call them that way, inside the condition, so that we don't pollute our outer scopes, and it makes our logic more consistent. So let's say we have like a long word that maybe we want to just check. Let's say we want to check if the string Golang, maybe we have a string called Golang, and then maybe we want to check if maybe Golang is, or the length of Golang is greater than 5, right? So mostly you do, or maybe if length of Golang, maybe Golang is greater than 5 and blah blah blah. But the neat thing about Golang conditions is that we can actually initialize variables in our conditions as well. So we can just say, oh, if n equal to maybe the length of Golang, and then if n is greater than 5, we'll just print, oh, long way, or maybe Golang is greater than 5. It has, let's see, n words. Yeah, this makes sense. So let's run our program. So it says Golang is greater than 5. It has 6 words. And so what we actually did over here was that instead of just doing if len of Golang is greater than 5, something like this, right? There might be some instances in your coding journey, or maybe there might be some instances when you're writing Go code that you might want to use the length of Golang in your condition, somewhere in your condition or somewhere in your program, and you might not want to be calling learn Golang every time. And so it gives us the ability to just define or initialize a variable and assign it to the length of this, so that we can just keep using it as and when we want in our condition. So this is how if statements in Golang work. So obviously we can do something called an else, because you can't do an if without an else. So we can do else fmt.println Golang is less than 5. So 5 like this. Sorry. Maybe we can even put this in a function, right? Because we learned about function. So we can do fun check, which will take a word string. It won't return anything because we are just printing. So we'll do if the length of this word is greater than 5, we'd say, oh, word is greater than 5. Word is greater than 5. If not, we'll say word is less than 5. So yeah, we can just call check. We just call check, and we'll say go long, and then we'll call check. Let's see, Ernest, check, maybe Kofi, check, maybe the boy is going to school. You know. Now let's run our program and see. Exactly. So when we call our check function, right, it tells us, oh, Golang is greater than 5. It has 6 words. NS is greater than 5. It has 6 words. Kofi is less than 5. The boy is going to school is greater than 5. And so we were able to use this n in our program. We can even add it over here. I'm not going to do that because of time. But the point is that we put this in a function that we call multiple times, instead of doing multiple if statements. That's also another advantage that functions give us. We can call them multiple times. So yes, that's about if conditions in Go. And there's also something called a switch statement. Now, switch statements also work just like if else blocks, but they are much more clearer, I would say, right? They evaluate top down automatically, and they also automatically break after a successful case. So we don't even need a break keyword like what we did in our for loops, right? The infinite loops. And so, yes, that's it's about switch statements. So there might be instances in your Go programming that you might want to check. You might want to check, let's say, a particular condition, and based on that condition, you want to do something. Obviously, there's the approach of using multiple if-else conditions. You can do if, you know, else. You can do this. You can do that. You can just have multiple if and else statements. But with switch statements, right? It automatically will break after the first matching case you give it. So you don't really need a break, and it's also much more cleaner than the normal if else statements that we know. So to declare a switch statement, let's say you want to check the day today is, right? Today is a Friday. So let's say maybe day equals, let's say Friday. Now let's say you want to check what day is today, right? Obviously we can do if day is equals to Monday, then we'll do this. Else we'll do this, etc., etc., etc. But with switch statements, we can just switch on the day. So whenever you use the switch keyword, you need to give it the particular variable or the particular thing, quote unquote, that are checking on. So in this case, it's the day that we are checking, right? So we'll just call a switch on a day, and switch statements need something called cases. So let's say if our case, or if today is, let's say Friday. Now let me not say Friday. If today is Saturday, we'll say, oh, fmt.println today is Saturday. And we can also add another case. We can do sorry. We can also add if case. Let's say Friday. Then we'd say end of week. You can also check multiple cases at once or on the same line. So you can do case Monday with a comma, and then Tuesday. And then we'd say, oh, let's print week just started. And by default, right? So with switch statements, obviously we are switching on the day with multiple cases, but let's say all the cases were we didn't meet all the cases, right? So let's say today was Wednesday. So Saturday is not equal to Wednesday, which means we won't do this. Friday is not equal to Wednesday, we won't do this. Monday and Tuesday are also not equal to Wednesday, we won't do this. If we want to do something regardless of the day today is, we need a default case as well, right? So we can do default. Sorry, I have to bring it here. Default, and there of this. So we can do default, and then we'll print any other day. So we can run our program, and then since today is Friday, it will print end of week. But let's say today was Wednesday. In this case, today is not Friday, today is not Saturday, today is not Monday, nor Tuesday. It's going to print any other day because Wednesday doesn't match any of our cases. So that's it. There's also something called type switches in Go that maybe you want to switch based on the type that a variable is, right? It's a bit advanced for our presentation today, so I'm not really going to go into it.
Do it, do it,
Oh,
do
okay.
it.
Cool. Right. So, I mean, type switches are great when you're working with interfaces and you don't know the concrete type ahead of time, right? So, let's say you have an interface, let's say var v interface equals, let's say 42. 42. So you can also switch on the type of this, right? Because you don't know the type ahead of time. Let's say you don't know the type that it is. So we can do maybe switch v dot type. So we switch on this, and then if let's say v is an integer, so if it's an int, maybe we'll print integer. If maybe it's a string, we'll do it's a string. If it's not an integer or a string and it's something else, right? We can just add our default and we'd say, oh, unknown type, because we don't know the type. So yeah, this is something that you might also want to keep note of when you're writing Go program. So we can run this, and yeah, it says it's an integer because obviously 42 is an integer, right? I think there's an inbuilt like function that you can call reflect dot is a type, yeah, that you can also use to check the type of a variable. So if let's say you have let's say name equals, let's say Ernest Sarfo, you can do maybe, oh, let's say fmt dot print line, name is of type, and maybe we'll call reflect dot type of name. Will this work? What are they saying? Cannot to reflect the type. It's missing a method align. I've forgotten how to use this, but it's there. It gives us the, let me see. Yeah, let's just get rid of this, but there's also something in the reflect package that you can use to check the type of variables. Maybe I have to look into it again, but yeah, so that's it for switch statements. Let's go ahead. And there's also something called defer statements where, mostly it's used for resource management, right? So and also most of the things that you defer are functions, and so deferred functions are executed in last in first out order, and only is executed after the surrounding function returns. So mostly you might want to use it for cleanup. Maybe you open the file and you want to close it, or you log the mutex somewhere in your program, or you want to end database transactions safely, right? You might want to defer the execution of whatever function or whatever thing that it is you want to do. And after the surrounding function or after the outer function has finished executing, only then will your deferred statement or your deferred function also execute. And so yeah, like I just said, it's mostly used for resource cleanup, right? So it will schedule your function call to run only after the surrounding function returns, even if it returns early or even if it returns an error or something. So let me do what do I do? Let's say a function that opens a file, right? So let's say func read file. Let's say we have a file called inputs.txt, and over here we have maybe hello world. So we'll do, oh, so there's this package in Go that allows us to open files. It's called OS. We can open file with os.open, and it will give it the file name. It takes it as a string. I believe so, yes. So we take the name as a string, and then we'll just do input.txt. So we'll give it input.txt, and it returns the file itself, and it also returns what's it called, an error, right? So in this case, this is something that I talked about earlier. So we can also assign whatever it is to our open function. So we can do maybe file and error equals to os.open, and then we can check if maybe there was an error while opening this file. We can check if error is not null. We can do fmt.print line error, and then we pass our error over here, and then we'll return. We'll return. Let's just return. Else, we will defer. Let's say we'll close our file because obviously after opening a file, or after opening a stream of input, you might want to close it, and then we'll just do fmt.print maybe reading file. So in this case, what actually happens is that we open our input.txt, we check if an error happened, and then we'll read the file. But after we print this reading file, we know that our function has finished executing because it has already executed the last statement in our function. Only then will this f.close actually come in, or only then will this defer statement actually run. Right. So this will only, let me add a comment that it runs at the end of the read file function like this. So maybe we can do read file, yeah, like this. Let's print this. I think it should. What is saying? Read file, no value. Okay, cool. Okay, so we can do this. So it says reading file. Obviously, we won't see the file being closed. So let me see. Let's say so we can just do format dot print line and say, oh, file is done. Let me see, finish reading file, closing it like this. So let's run it again. Okay. This is not used. Let me just add this so that it will say that we used it. So that's another neat thing about Golang. You can't initialize, variables without using them. So if it's there, you have to use it somewhere. So yes, it prints reading file before it comes to print or finish reading file, closing it. And this is the file. Obviously, it's a pointer to wherever the file is in memory. So it's not really the value that we need. But the point is that the defer statement actually was executed only after the surrounding function or the last statement in our read file function was executed. So this is something that you might want to keep track of. And also, defer statements or defer statements are executed in the last in first out order. It means that if you have multiple defer statements, right, the last one will be first and the first one will be last, essentially. So let's say we have maybe defer, let's see, third, and then and is there a way I can duplicate this line? Okay, and do this. Let's say you have this and you have this. So let's call this second first. Let me add another one at the top called fourth. So what actually happens is that we are deferring all of this. So the first to execute, will be the last. So essentially, the it's last in first out, like a stack. If you know what stacks are, that's how stacks are. So let me just run the program so that you see what I'm talking about. So you see it prints first, second, third, and fourth. So it's like the last thing came the first, second, second to last, blah blah blah, etc. etc. So this is also another nifty thing about the first statements. So yeah, one thing I'd also want to say is that when it comes to control flow or when it comes to the whole if else, switch, the first and whatnot in Go, it's really about keeping things simple. One loop keyword, straightforward conditions, clean branching, and defer, which saves you from resource leaks. So it's something that you might be using a lot in your Go programs. If you are here and you are an experienced programmer, there might be times where maybe you forgot to close a file or you forgot to close a DB connection, right? So in Go, there's defer, so that you can just defer that and what's not. Mostly if you're coming from like a Java or any other language kind of background, you forget, you just open and you don't close it, and whatever happens will happen. But in Go, there's this defer for you. So yeah, that's it. And yeah, so this brings me to the end of my presentation. So we've covered packages and imports, we've covered what variables and constants are. We've also spoken a lot about functions and control flow, and we wrapped it up with the first statement. So at this point, I would like to open the floor for any questions. If you have maybe questions, comments, clarifications, or if you've eaten and you're full and you just want to talk to, the floor is yours. You can just raise your hand and talk. But